Be nice. Hey. Mm. It's a race. Who will be here first? Cyber Bob. Oh! That was good. Oh my god, that was good. And Matt is third. Oh, that was just so good. I wish I had an index printer. Oh, and the H2C is on its way too. Bamboo's version of Tool Changer. I wish. Ah, my baby. Ender was about to start some shit with Noel, and Noel was like, "I'm not having none of it." Nice. Oof. Hey, this will let me open them. Nice. Is it actually going to let me load all these? Nice. I'd be happy with anything multicolor. Mm. Oh. 2,400. Holy crap. Hi, baby. Come here. Come here. Don't be a dick. Come here. Give me that tail. I got that tail. Yeah. That's a lot of freaking money. Although for a tool changer is not a lot of money. I mean, what's the ready to go tool changer from Bamboo or Prusa cost? Really? The Prusa tool changer is 1,500 bucks. I thought it was like $5,000. Yeah, it's $4,000 for the Prusa. And this is a, what's the build volume? 360 cubed. That's the H2C, right? H2C. 41. Printers. Prusa Core 1. Why is it showing me this? There it goes. So you're looking at $1,300. That is for a single tool head. Good morning, Big Bad Joe. Why? Come on, stop messing with me. Just do what I say. What are you doing? I mean, what the fuck is your problem? Why won't you go where I'm telling you to go? All right, where do you get the tool changer for the Core 1? I don't see anywhere where the fuck is this coming from? Why is it showing me this? What a pain. Oh, it's always been there in the background. This is the menu I'm loading. That's why it's doing that. Ah. Oh, that's right. You said index. This one is only 305. So the Prusa the tool changer from Prusa is bigger. Hmm. And it does 8, huh? Whatever. Jesus. Just stop nagging me. How do you find it? I hate when sites make it difficult to find this kind of stuff. It's like, why would this stuff be so hard to find? I doubt it. I doubt I have a machine that could use the Bondtech system. All of my machines are standard 3 motor bed slingers. -1 spots available. Why we're doing pre-orders? Because you're doing your own Kickstarter. This is a Kickstarter. That's what this is. Except from a company you could trust. Yeah, I bet. Everybody wants this. That's exactly what this is. This is a Kickstarter. This is no different than a company using Kickstarter. Except, you could probably trust Bondtech. I love the fact that they accounted for the legitimate wear concerns by using induction coils instead of depending on pogo pins to hold up, because when you're doing thousands and thousands and thousands of color changes, the even pogo pins will eventually wear out when you just keep doing this over and 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 over again. And the only question I have though is induction coils create a lot of heat. Now, the induction coils that just transfer data, that's not going to be a big deal. But the induction coils that are actually heating up the hot end, my concern is, well, you're going to have the same kind of wear and tear because the induction coils are going to expand and contract, expand and contract, expand and contract as they heat up. I wonder how much testing they've done on that. Has anybody done testing on that? Has anybody tried to use induction coils that much? Has anybody tried to use wireless connections in this manner before? It'll certainly be interesting to see what happens. And it might not even be that big a deal as long as these parts are serviceable. The nice thing is, if your hot end carriage wears out, you only have one. And I can't imagine these remote units would be all that expensive. So the wear issue might be a non-issue. Especially if they're selling it that cheap. What is the earring? Oh, these. It's like a little two-piece thing. So the boot is hanging from the hat, and the hat hangs from your ear. I just thought they were kind of cool. Hey, I'm on my stream. What's up? Okay. Everything okay? Okay. All right. Bye. Yeah, I thought they're pretty neat. So it's except they didn't invert them. So this one's facing backwards. This one's facing frontwards. If they a little higher quality, and they would have done a reverse mold so that the two were facing forward. But that's all right. No one's gonna notice. um, so I have ordered all the parts that I need for putting together the flashlights. I might even try selling a couple of them to fund the whole project. But basically, there are people who've been taking these lights, which are actually pretty damn nice, and turning them into regular flashlights. You can find them on YouTube, where they take the little $2 keychain light and they turn it into a flashlight. And basically, what they're doing is they open it up. This pops off, and they just snip the battery off and replace the battery with a bigger battery. And so now you have a 18650 powered flashlight that'll last a whole lot longer than the little tiny polymer pack that comes inside there. And that cob puts out a pretty damn decent amount of light. And it already has the USB-C charging circuit, so you literally only have to replace the battery. But I want to do a little bit more than that. So here's the things that I've gotten. First, I got a Type-C PD trigger, so I can set this for 5 volts, so that it'll communicate correctly with whatever USB-C it'll communicate correctly with whatever USB-C charger you plug into it. Because there's like a resistor setup in here that tells the charger I'm this, and if you don't have that, it won't charge at all. So you need a PD trigger. I got 2 of these batteries. I got the 2-pack. This one, of course, it's a little cheaper now. But these are 20 amp hour lithium iron phosphate batteries. That's a lot of juice for running a little 5-watt flashlight. And then, because I want this to last forever, I got some nice 35 by 35 heat sinks, copper heat sinks. This is one of the most expensive parts next to the battery. Only the batteries are more expensive. I also got this. For $2.93, you can get 20 of the little cob emitters that come in those little flashlights. So there's that little keychain flashlight. This is the emitter it uses. So for slightly more than the cost of one flashlight, I get 20 of these emitters. I also got some JST plugs so that it's more serviceable. I got these nice heavy-duty switches. It's a dual position double throw switch. So basically one side will be high, one side will be low. So I'm going to have a what's called a firefly mode, where it provides just enough light for you to see what's on a desk or to read a book or something like that. And then you'll have a bright mode for but not crazy bright, enough that you can leave it like that 24/7 and not burn up the LED. This is the BMS that I got. So this is the 12 amp BMS. We're only going to be pushing 3 amps. The idea is to have components that are way overbuilt for what it's doing. Because again, I want this to be a forever flashlight. I want this thing to last essentially forever. And then this was the real kicker. This is the part I was really looking for. Because this is the reason you have to use the original flashlight. This eliminates the need to use the original flashlight. This gives me variable. This is a constant current LED driver. So instead of using a resistor, which wastes power, this is an actual IC to current restrict the power going to the LED. And the nice thing about this is this one's adjustable. So you just turn this pot and you can adjust your power output. And so, like, for example, this LED is rated at 5 watts, so I'm going to probably run it at 4 watts. I'm going to run it at 80% of its rating, so that it'll last a whole hell of a lot longer. And probably be almost as bright. And well, what I'm going to do is these are super duper cheap. $5.65 for 20 of them. It costs nothing. They're so goddamn cheap. Let's see. Here's all the connections. That's weird. Why do they call them weird names? I never understood that. Why not just say LED positive, negative, input positive, negative? I'm guessing V1 is my input positive and G is my negative. Why they're split apart, I have no idea. And then CE and LED are the LED connections, I'm guessing. So your power input would come here, and then your LED would connect to here. And then you'd adjust this pot for your power output. And so there will be two of these in the flashlight. One will connect to one side of this switch, and the other will connect to the other side of this switch. So you have, high, low, and off. No stupid blink mode. And then this, the output from here will go to the switch, and the switch will go to the drivers, and the drivers will go to the LEDs. This way the BMS can cut off the power and prevent you from over discharging or over currenting. And, but this was the real kicker. This is what's going to make this a really nice flashlight, is having this little tiny circuit board. Does it give dimensions? I hope so. There it is. 17 by 10. Okay. And that's basically it. Hey, drone shots. So I'm probably the first one's going to be made out of probably PETG or PCTG, and then I plan to have TPU overlays for the cap and the head for drop protection, so that if you drop it, it doesn't destroy it. So I guess the first thing is to start designing all the components. I'm going to make everything 5 millimeters thick just to keep it simple. So it's going to be 17 by 10, or probably 3 millimeters thick. I doubt it's even that thick. We're going to make these all green to indicate they're circuit boards. Let's see, where is the BMS? Does it give me the dimensions anywhere? I don't think it does. I don't know if it gives me the dimensions anywhere. Usually they give you a image with the dimensions. So I have no idea how big this is. How are you doing, drone shots? Oh, you get a kick out of the shirt I got too. Check it out. It's a UFO abduction of a gingerbread man with a gingerbread saucer. I love it. Okay, so that's not going to help. Does this have dimensions anywhere? Oh, this just needs a hole. And then you thread through the hole. And the switch is going to be recessed, so that you can't accidentally flip a switch. You got to stick your finger in a recess and flip that switch. Let's see, where is the flashlight or the battery? This one, there is one with dimensions. Here we go. So it is 130 by 40.5. We're just going to do 130 by 41. 130 by 41. Hello, Cassandra. Boy, that is a big battery. Then 163, let's call that 3 millimeters. Could be 5. Doesn't tell me what threading that is. Three. It's probably 3. Oh, it might be 5. I hit tab and you ignored the fact it won't let me hit tab. It won't let me hit tab. It won't show me the other dimension. That's weird. Oh, Jesus Christ. It's a line on you, here, here, and here. And then we join them. Oh, wait a minute. We can do this a little bit better. Make it silver, and then do bundle. All right, there's our battery. Now this one is going to be 35 by 35 by 11. And we're going to, just for the hell of it, because I can, all right, Control D. Let's shrink you a little bit. That looks good. That's our heatsink. Okay. I don't know how big this switch is. I'll just have to make sure I have plenty of space for it for now. Considering how big the battery is, I shouldn't have a problem with space. I wish I knew how big this board was. I can't imagine it's that big. That's a 6-pin. That's a MOSFET. Oh, there's some pictures. But nothing relative. Like, how big is that relative to what? I don't know how big it is. I know how big that is, but not how big the other one is. This one has dimensions. This one is 33 by 33. 25 point. By, and it won't let me tab to the next one because it sucks. 2. Why do you always have to annoy me? Radius. Steps. Let's go again to 11. Yeah, that'll work. Let's make the radius 2. It's 1. 5. That looks good. Right. Okay. Let's make this 1 millimeter thick. That's going to be silver. Drop. Then we could take Control D, lift it up 1 millimeter, change it to yellow, make it 25.4. Go. I did something wrong on that. Oh, it's 33 by 33. So that is correct. Okay. This is probably shorter. Okay. And this is 15. Seriously? Why do you got to keep jumbling everything? I can guess. It's just an approximation. Jesus Christ, get out of my face. Hey, 3D Medic. There we go. There we go. All right. So there's our LED emitter. That emitter is going to be attached to this. Okay. Good. So that's going to be the front of the flashlight. I have to assign a space to accept this. Boy, that is a big battery. Wow. Okay. Okay. Okay, so this is 35 by 35. So let's make this 45 by 45. And 45, I guess. Okay, radius. And I want it to be chunky like that. Means I need to change this 20. I want that radius to be editable. I have to do it in here. Okay. Oh, I might be able to put all the electronics in the head. And then put the yeah, I think I'll put the electronics in the head, and then the switch will be at the top of the handle, which will have the battery. But the BMS has to go in the handle with the battery. What about the PD trigger? How big is this? Really no dimensions at all? Of course there's no dimensions. I'll have to wait till it comes in. And it doesn't tell me how big it is. I could probably find it eventually. Well, we know how wide a USB-C PD port is. You can guess. I might even desolder this and just solder the JST connector directly to it. Yeah, it's a clean solder right there. Just desolder the junction and solder the wires directly to the board. How do I want to do this? I have an interesting idea for how to print that. I might actually put a non-3D printed part in here. just for durability. Now that's an interesting idea. Although I only need openings on the left and right on the one side. Let's make this 50. 60 by 60. That doesn't work. 60 by 60. That's only a little over 2 inches. So I don't want this to be a tiny flashlight. I want it to be pretty chunky. So this is 35 by 12. I might even be able to friction fit this. Can I make this? Yes, I can. You rotate it 45 degrees. Okay. This could work. Let's make the top radius is going to be, it's 25, right? Yeah. So let's make it 26, which would be 13. Is that correct? I don't think it is. No, it's not. Okay. All right, so I got to do the math on this. I remember how to do this math. So we have 13 times 13, 169 times plus 169. That's c squared, 338, and I need the square root of that. How do I get square root on this calculator? Specific. You just deleted what I did? Are you kidding me? Why the hell would you do that? Did I say 338? I just want to do it again. 169 plus 169. Yeah, it's 338 square root equals. We have to do it this way. It's 18.38477. What am I doing? It's not 13, it's 25. We're doing 26. Because I was doing radius. Because I'm an idiot. 26 times 26. 676 plus 676. 1352. Square root of 1352 is 36.769. So this needs to be, then we need half of that divided by, divided by 2. So we need 18.384. 384. And that's correct. Okay. So the bottom just needs to be bigger than that Probably up that angle there. Looks pretty good to me. Drop. Okay. Hide this. Attach you to there. And we're going to make you 12.5. Why did you ignore me? And then it's going to be 36 by 36. No, 34 by 34. Okay. Line on you here and here. Okay. Let's join these two together. Bring back the other parts. Oh, wait a minute. This has got to be extended. This is going to have to come out this way. This is going to have to come out this way. Yeah, physical therapy is always rough. If it doesn't hurt, it ain't working. Okay, now how deep do I want to put it? I'll put it at least probably at least 6. -6. Is that deep enough for strength though? Why does it keep jumping? That'll give me 8 millimeters of plastic. Okay, let's do this. Let's increase the base. Yeah, that looks good. Join you. Then we join you. Okay. Now that should slide directly into that. And then you're gonna let me click that. This is 35, right? Yep. So we're gonna make this 30. 30 by 30. Slice it all the way through. Then align it. And join. There. That looks pretty nice. Yeah. Okay, so now this should fit directly in here. Not what I wanted. There. Now that will slide inside there. Oh, wait a minute. I did do that wrong. Hang on. Yeah, that's wrong. Yeah, this needs to be 36. So 35 and 36. There. Now that should be a pretty snug fit to slide that into there. I might have to put a little notch right here so that this can fit, because the actual LED cob will sit proud. Doesn't give me dimensions though. So the actual LED cob is going to sit proud of this array. So I'm probably going to have to put a notch in there to allow that to fit. Otherwise, it'll scrape it off. But that should work out nice. I'll have to make sure it goes in the correct direction though, so that these solder pads also sit within the notch. But yeah, that should work. And then these solder pads don't need a channel because they'll be sitting right here, which means they could just come in through these channels in the heatsink and then extend into the bottom of the. Why don't I see the rest of this? Where's my hole? Really, that's how you're gonna play this? You're gonna do that to me, huh? You douchebag. I mean, you're really gonna do that? Suck it, filthy wanker. Really, really, you gonna dick at me like that? There we go. Now we have an opening inside there. All right. Good. And I will probably print this in 2 pieces. I could print it in 1 piece and just remove the support, but man, I hate support so much. At this point, I would literally rather just put 4 screws into here to put this together without having to use support. Yeah, I think I might actually do that. Yeah, I'll probably print this in 2 pieces because I just don't want to deal with the support. And then I can mount most of the electronics on these walls here. So let's join these together as a bundle group. I'm actually thinking I should make this a little longer, the head. Give me more space for the electronics. I might even be able to VHB most of the electronics using a little VHB tape. I don't really need to worry about cooling for the drivers or the BMS because I'm going to be undervolting this by so much. I'm gonna yeah, let's make this longer. So this, let's make the height 80. Really? I'm just going to do it manually because I don't like the fact that you want it to go the other way. Yeah, I like that. In fact, because of the way I'm doing this, I could actually, I could print this on the side. And then I could print it one piece. Really? Come on. Why do you got to do that? Yeah, if I print it like that, there should be no supports. Oh, yeah. We're doing that. The only overhang will be this, and that doesn't matter. Okay. Well, I should have thought of that. Yeah, I'm okay with that. I mean, this might get a little sloppy right here, but again, I'm okay with that. Oh, there is one thing I want to change, though. This shouldn't be a knife edge. We'll have to see how it prints. This should be a squared off edge. Okay. So this is going to go down here. Boy, that is a big boy, isn't it? Because theoretically, I could print it so that this piece right here is a separate piece and then screws in. That'll make getting to the electronics really easy. Especially since we're going to have a TPU head on top of this, which will cover that up. I gotta think about that. If I could do it in one piece, I'd rather do it in one piece. Although that's only 1 inch right there. It looks huge, but it's not. It's 1 inch. That's not a whole lot of space to work with. I do think I need to put a piece here. Let's make it 26. And let's put this here. Drop. Then add 2 millimeters. Actually, 1 millimeter is probably enough. Yeah, 1 millimeter is probably enough. Yeah, let's do that. Oh, that'll give me my shelf too. So let's unlink you, link you with you, add you, then join you like that. All right, that gives me my 1 millimeter shelf, which will allow this to clear the LED cob and also clear the solder joints. I can adjust that as necessary. Okay. Yeah, I'm okay with that. All right, now, how am I going to attach these two together? Let's do this and this. So that's going to be about that big. There's enough space. Yeah, there's enough space for threading. Let's go grab a bolt. Excuse me. I did not ask you to do that. Bolt. There it is. Although, ooh, I can't make it part of the base. Yes, I can. There's a way I can do that. Let's grab you and you. Might as well grab the big one. Import. Nut. Come on. Okay. Come on. Come on. So we take this and this and we put them together. Okay, and we take these and we join them. Put this face here so that I can scale like this. Yeah, I should have grabbed a smaller one. Oh well. Yes, but I didn't get anything for it. It might be because it hasn't shipped yet. It says it hasn't shipped. Here, I'll show you. I did find it. It looks like I'm not going to make the bonus for this month because I'm still $2,000 short. Let's see. That would have been nice. Let's see, view full report. Let me go to earnings. And it was one of this one I think it was. Yeah, see, it says here, this is the guitar, but it says items shipped 0, and I think that's why the commission is 0. Hasn't shipped yet? Let's see. As far as the... Oh, interesting. It says ship 0, commission 0. For whatever reason, I didn't get nothing for that. I don't know why. Pet G. Somebody ordered Pet G. I got 45 cents for that. Let's go back to all dates. Let's check before then. Here we go. Overture PLA. I got 40 cents. Someone ordered a 2 terabyte M2 drive. I got $5 for that. I always do that. I hit the back button. You can't hit the back button. It breaks it when you hit the back button. Boy, that is weird. I wonder why I did that. Reusable cable ties? Oh, are those the metal ones? Huh? How does that work? Oh, it's Velcro. Okay. That's how that works. It's probably nothing you did. It's just, there's no rhyme or reason to it. It just, sometimes that's what it does. So we do this. Let's do a transparent. The question is, does the battery fit through there? I think it does. I think I need to make this bigger. Let's do that. Let's do that. Oh yeah, that's the notch. Okay. Let's hide this. Let's make this 80 by 80. Hate the fact that I can't do that. Make this 100. Okay. Is that still centered? Yes, it's still centered. Okay. So this, and oh, that's already one piece. Okay. Join. Right. You need to be extended like that. We could probably also bring you up a bit. No, I got to go all the way into here. Okay. Join. Like that. Okay. Let's bring this out. Okay. Let's transparent this. Why are you doing that? Because I need to do that. Okay. I think I can make that a little bigger now. Mm-hmm. Okay. That's the wrong size. Yeah, that's the wrong size. Uh, I need to put the bolt inside there. Oh, yeah, what I need to do. But I got the scaling good. This can't be the cut piece. Okay, there is. Is that enough space? Yeah, I think that's enough space. Okay, let's figure this out. So I want to make this at least 45. Although, no, it doesn't have to have that much space. Because just a wire has to pass. Okay, that's my spacing. Control D. Now we put our work plane here, and we scale. Why did you do that? I don't know why I did that. We scale up until we cover the threaded area. $72 by $72. Okay. Let's just do this. A line on you here and here. That works. Okay. Okay. Now, can I use the new intersect tool? There is a way to do that. I think I just need to duplicate this, scale it like this. This. I think I do this. That. Turn this into a hole. Then if I do this, I should have an... Where is the intersect? It's not available yet? Where's the intersect option? Because I could use that right now. Actually, I don't need to. I just realized. All I have to do is this. There. That's all I need to do. Don't overcomplicate it. Oh, come on. Why do you gotta go sideways? Because I still have the work plane moved. It's my fault. Oh, man. How do I want to do this? Well, I need two of these, actually. Oh, D. Need one for the end cap. Um, let's see. Let's put a work plane here. So this is 70. See, look at that. See, it did it again. It's 72, not 72.01. Ooh, that annoys me. That annoys me so much. I know when I come back, it's gonna change it again. It's gonna do it again. It's a little quirk in Tinkercad. How long do the frostbite plates last? Like, I know they wear out over time, don't they? Okay, so first things first, I gotta put a hole in here. That is 71. 71 by 71. Let's do this first. You and you. That is not what I wanted. You and you. Center on you. That's right. Now I need you to come out here. And I need you to line here. Take you and you. And, oh, wait a minute. Let's cut a hole again. Let's duplicate you again. You and you. I'm going to join like this. Oh, wow. That's not bad. There it is. Okay. Oh. Let's put one of you down here. Let's do this. You and you are going to align on you here. Then we're going to take you and chop you apart. And take you two and join. There we go. That's our threaded flashlight insert. Okay. Um, how do I want to do this? That's my minimum. All right, figure it out. Let's do this. Drop. Let's bring 2 millimeters. Let's do 3 millimeters of clearance. Okay. Let's add a cylinder. Hang on. Yeah, let's do this. 75 by 75. Okay. Let's do you and you. Center on you. Here and here. No, we don't want to thread the whole thing. Let's do this. Let's go 1 millimeter up. And let's cut. Let's do this. Okay. Let's do minus 80, 90. Okay, so I should be able to join these two. That. Okay. Okay, it doesn't need to be that big. This. So this can be smaller. Yeah, I can get away with 73. Okay. Is this symmetrical? Yes. Okay, this could be a lot bigger. Let's go 50-50. Okay, we take you two, center on you, here and here. How does that look? That looks good to me. It's not puncturing the side. Let's see, we don't want you to be transparent anymore. I want you to join with you. What's the problem here? You and you. Okay, now we take this and this. Join. Okay. Oh, that's all one piece. I forgot about that. Save a copy over here. Okay, we take these pieces here. We align them on this one, on the end. And this gets cut out of this. And this joins this. Okay. All right, plenty of room in there. Oh, that does not need to be that long. That doesn't need to be anywhere near that long. And okay. Really? All right, that's enough room for all the electronics in there. Let's make this a little longer. No, I don't have to make it longer. I just need to pull this out. Why can't I pick that? Oh. Come on. This needs to come out. Did I happen to line that up? No way. There we go. Okay, let's chop a little bit off of this. I think that's plenty. This. Do this. Line you here. 36.83. Does it have to be a weird number? 36.83. All right. So now this gets joined with this. Off transparent. Join that with this. Transparent again. There we go. That is plenty of space. Yeah, that's plenty of space. Oh, man. I still have to put a notch in here for the switch, since I don't have space for the switch yet. This goes 90. There. Okay. How do I want to do this? Ooh, that's definitely not what I wanted to do. That's more like it. And how big did I make this? 73. Actually, none of that matters. Why are you doing that? D. Really? Come on. Really? I missed a tiny little bit. You gotta dick with me? Okay. What a pest. Okay. Gotta mess with me. Ah. Okay. Okay, next thing I want to do is do this. Increase the radius. Why did you do that? You and you. Now we increase wall thickness. Why do you keep doing that? Where the hell does that keep coming from? Oh, my finger keeps tapping the right click button. Can I do this? No. Nope, I can't use the keys for that. I go 5. Yeah, that'll work. This is 73. by 73. And we're going to make it shorter. That looks good to me. You and you align on you here and here. Then put this here. Grab this and drop it. Then we're going to do negative 0.1 to make sure they actually overlap. Okay. Oh, interesting. I definitely want to do that. How do I do that? Or is it already done? No, it's not. I'm going to want to put a cone there. This. Like that. Okay. 73, 35, 36.5. Line. Oh, there, there. Now I could just adjust the height until I get that. Wait a minute. First, let's put a cut disc right there. Then we adjust the height. Why are you messing with me? Well, this doesn't look like the right size. Come on. Move the damn thing. What the hell? Oh. Minus 0.3. Why did you do that? Minus 0.3. Okay. That looks like about the right spot. And there. You can see that I grabbed it. It's red. Why wouldn't it let me drag it? Because it likes being a pain in the ass. You and you. And you. And you. Why? Stop arguing with me. Here. End cap. Come on. How is that misaligned? That's exactly the same size. And yet somehow it's not. It got moved somehow. There we go. Now that bevel right there will perfectly fit this bevel right here. Ew. This will slip right in there like that. Now, did it go too far? No, it goes inside, which is fine. Okay. Good. Okay. I can live with this. Now the plan is I'm going to print this in TPU, which is like 2 walls and a light amount of infill, so it's squishy. So this way, if you drop it on the tail cap, it'll just bounce. Okay. All right. I like it. I think that'll work. I'd like to make this something other than a square. It kind of looks ugly, doesn't it? But the nice thing about a square is it doesn't roll. Now, what I should do, and I just might do this, since it's got so much beef in it now, I should print this half and this half as 2 separate pieces. I would eliminate the need for this channel at all. and then print this top piece here in TPU and have it screw directly into this. You know, something I think that's exactly what I'm going to do. Yeah. Yeah, I think that's exactly what I'm going to do. For now, I'm going to wait until I have the parts to get the measurements. But yeah, I think I'm going to print, I think I'm going to beef up this top a little bit here, or actually just make it from here up. So split it right here. And then this will insert from the backside. This is going to still be open for airflow. And since we're only dissipating 4 watts into a pretty big chunk of copper, I don't think I need a fan. In fact, I know I don't need a fan because the original one doesn't need a fan. Yeah. Hmm. Man, it's chilly in here. Okay. Can you guys see any issues or things I should improve or... Ooh, that is going in too far. Yeah, that's going in too far. I'm gonna have to shorten that. Yeah, that's going too far. So this needs to go out to here, like that. How far did I move that? 1, 2, 3, 4, 5. 5 millimeters? Yeah. Okay. This has to all come apart. Oh, it already is. Okay. Joined. Bring it back. There we go. And now we're not going too far. And then what I'll probably do is cut a piece of foam to put in this end and this end around the battery. Create like a sabot for the battery. Yeah, and I think by making this a solid block, this out of TPU and this out of TPU, and this is pretty damn thick, I think we're going to be okay. And we are not going too far there. That looks good. Yeah. And there is plenty of meat for the screws. I'll probably just use like self-tapping roof screws or something like that. Just, a simple screw. think you need to stop, soften up the rectangle a bit. What do you mean stop, soften up the rectangle a bit? I'm guessing stop is a mistype. The problem is the heatsink is a rectangle. I mean, I could try to make this an octagon, but there's lots of issues with that. A pentagon would be better. Oh, we could try it. Hang on. Let's do this. Control D. We could play around with different shapes. Okay. Okay. Let's see. Oh, I can't do that. I thought I can increase the number of sides. I guess I'm not allowed to do that. A hexagon would probably be the best bet. Okay. This is 80. So let's do this the same size. 80. We're going to make this 100 millimeters long. Not what I wanted to do. Okay, we can bevel. No, because that, yeah, I guess um, yeah, you're right, I could do that. Okay. Excuse me, I said drop. Oh, this one's not dropped. Hang on. Bundle, drop, unbundle. Okay. Well, first, should I stay with a square or should I go with a hexagon? I think a hexagon would fit. Let's do this. This should be 80 by 80. No, it's 90. It doesn't matter. It's gonna symmetrically sit. It'll work. Excuse me. What the hell's your problem? Pick them both. Okay. Do that. Now, how is that not the exact same size? That should be precisely the same size. 100. 100. Unless it got shifted. Yeah, it's possible it got shifted. Let's try this again. Align here. Okay, let's do that. So let's do this and this. This and this. That works. I'm kind of digging the hexagon too. So more like that, you mean? And then I could also still bevel the end of this. I just don't know if that'll look good or not. Let's try it. I think what I need to do. Let's do this. Let's do that. Base. Height. Size. Line. You. Here. Here. Okay. Increase the base radius until we just touch. Come on. 26. That looks good. And now we increase the height. No, 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 no. Wrong one. Increase the top radius. If I keep hitting that damn right mouse button, that's so annoying. Why can't? No idea what it's doing. No idea why it's doing that. I don't know why I did that. I must have hit something. This has to come out until it touches right there. Okay. Now, the base of this. Yeah, we're so changing that. 92 by 92. Yeah, I ain't dealing with that crap. You and you. Then do a cylinder. Increase the number of sides. It doesn't really matter. Come on. Why? Why is it 19.99? Why? Did I mess this up somehow? How did I do that? It's not symmetrical. One of these is this one never got changed. Shit. Come on. Go. Now, I turn you into a hole. I join you with you. And it refused to do what I told it to do. Join you with you. Join. Turn you into a hole. And join you with you. That's all right. This is what we do. And now, there. What the hell are you? What? Wow, okay. I know how to fix that. I was like, whatever. 93 by 93. Now that I have the shape, all I got to do is realign. I'm actually liking the hexagon. I got a thing for hexagons. There we go. Yeah, I'm okay with that. What do you think? I could probably get away with doing even more. Oh, wait a minute. No, I can't do that. Can I? No, that'll keep making it smaller. What I would have to do. Let's do this. Boy, working 3D, 2D is so interesting sometimes. It's like the programs just like puke their guts all over the place. Okay, we do this. There we go. That way, this part doesn't change. What we could do is we could bring this. We could bring this all the way up to here. Yep. Of course. You've always got to do that little bit of a shift, don't you? There. Okay. That works. I'm totally okay with that. Yeah. I can live with that. That looks nice. And you're right, it does look better than the square one. All right, let's grab this, join it as a bundle group. Control D, select you, move the work plane to here, align here, there, and there. So you're just going to ignore the fact that I clicked that? You're just going to pretend I didn't do it? Is that how we're going to do this? Because it was too close to the hitbox of this. So it knows I hit it, but because it's a hitbox issue. Oh, there. Yeah, I can live with that. I like it. It makes the head look a little scrawny, but I'm okay with that. Oh, that's not good. we gotta scale it up a little bit. Actually, no. What we can do is, yeah, we gotta beef this up. Um, this. Let's grab this, bring it out here. Really? Come on. You out here. Separate you. Hide you. Separate you again. Separate you again. Why does it always have to be these stupid dark colors? Okay, so take this and this. And actually first, I think I need to make this a bigger. So let's make this 95 by 95. Okay, then we take this and this. Why do you keep doing that? It's unselecting. Oh, I'm picking the shroud, but it looks transparent. What a pain sometimes. It's like, come on, work with me. Okay, join. That should not have happened. I made it bigger. Unless I made everything bigger somehow? Okay, let's try just rejoining this and see if I get the right shape. Oh, it's cutting into this. Oh, I know what it's doing. We should be okay. Okay. E5 by 95. Actually, we can go a whole lot bigger. Let's just go 100. No, 99 by 9. Let's see what that does. Take these two, align, I need to touch you here and here. Okay. Now, stretch this out. Take you, and you. Okay. Why didn't that... Whoa, what did I just do? You, and you. Oh, I'm doing the same thing again. Come on, fucking rotate. Oh, it won't let me. It's too big. Where do I get that? I do this? That might work. There we go. Now we take all this, do that, and then we bring this back, and there we go. We're almost perfect. Okay, so we gotta go just a hair bigger. Okay. So let's go 100 by 100. Okay, so temporarily I have to go like this so that I can center this. And you gotta be there, there. Okay. Now I can bring this back out here like that. Do that. And and that. There we go. That's nice and smooth now. Perfect. What do you think? Is that better? And it still has just enough that it should. Well, it's probably going to roll now because it's going to sit on this edge here. There's a good chance it's going to roll now. Yeah, it's going to sit on this edge. It's going to sit on this point and this point. So the only problem is now it's going to roll. Although, no, I'm not going to do that either. I can, let's just put this back in here and see what it looks like. Drop. Okay. What I really need to do is make this head a little bit bigger. Or bring this back so that my flat part... No, that won't work either. That's the only thing I don't like is now it's going to roll. Although when I put a TPU top on this, if I do the top instead of printing this top part in TPU, if I just put a ring that goes on top of it in TPU, that should lift it enough to stop rolling. No, I really love the way that flush fits. That's such a nice joint that I made there. I really don't want to screw that up. I love that fit. Ah. Or comment. I know what I need to do. It's just really hard to do it. I need to make the head bigger. I mean, that's what I need to do. I need to make the head bigger. I'll think about that later. See, if this head was like 10 millimeters bigger, 5 millimeters on each side, that would make this the point that touches instead of this the point that touches. So you can see here. See, right now, this is sitting up off the ground. If this were to sit so that this is on the ground, then this isn't the surface that's touching the table. This is the surface that's touching the table. And that point right there is round. So what I need to do is I need to make that cone. So that cone that I used to cut into the hexagon, that cone needs to be steeper. So that when it right now it's shaped more like this. And so when it or like this, and when it sits on the table, this point's going to touch instead of this point. And so what I need to do is I need to make the actual hexagon head that has to, it's right now it's shaped like this. It needs to be shaped more like this. But I could also fix that simply by when I print the TPU ring to go onto the end of the flashlight, because well, see, the reason flashlights tend to obliterate when they hit the ground is because of G-forces. A flashlight hitting when something like a flashlight hits the ground, it's a relatively solid, immovable object, and it's made of plastic, and plastic is, relatively speaking, brittle. And when you have that much weight with all those batteries inside and stuff, and you hit the ground, you're talking, several hundred G's of impact force. It's only for a fraction of a second, but that's all it needs. Boom, and the flashlight blows apart. So by having TPU on the ends, you're still experiencing the same joules of energy when you hit the ground. But now instead of, 2 or 300 G's of impact force over 0.01 seconds, now it's or 0.001 seconds. Now it's hang on a second. Now it's 30 G's of impact force over 0.1 seconds. And that's enough to be within the survivable range of the materials. So you only need a tiny little bit of give to be able to make it survivable. Yeah. What are you doing? What do you have to get? Ah. That'll change. Hi, little critter. Hi. Smart ass. All right. I think we got most of the flashlight design. I'm designing a forever flashlight. No. Okay. You got it. Okay. Bye. But any kind of give at all is going to dramatically improve survivability because it's going to spread the G-forces over a larger period of time. And that's all you need to do. If you could just get it down to tenths of a second instead of hundredths of a second, that's usually enough. That's usually enough to fix survivability. Ah, the feeder just went off. Well, you're not going to go eat? Huh? You got up. You know you want to. You greedy little pig. But yeah. I mean, what are you gonna do? It should work. So what I'll do is I'll make a TPU ring that'll fit over this. So with that in mind, there is a change I do want to make. I want to have this be more like this. Actually, that'll also improve the angle so that I have someplace for that ring to go. Actually, that might improve the angle enough. Just doing that. Boy, this is really struggling. Oh. Derp. There we go. Now we take this, join, this, join. Well, that just might be enough to do that by itself. No, that's still the high point, but that's okay. Now I've pushed it back so we have a little straight edge line here. And now I can print a little TPU donut to go around this. And that TPU donut will give it the shock absorption it needs. And also, it'll be the anti-roll ring. Okay. That works. Oh, man. Actually, we can now Control D this. Starting to piss me off. Yep. This will work. Except I won't need this one. We take this, turn it into that. Hang on, nope. Let's do this. Come on. Delete. No, I don't want to delete it. I want to split it apart, actually. Oh, come on. There we go. Okay. Let's do this. Okay. Put you out here. I need that. I don't need this. Okay. I should be able to get away with doing this. That should work. Okay. Yep, that should work. Now I should be able to do this. Okay. No, I don't. I shouldn't need this because I do still need this hole. So these two I can join together. Okay. Now we need another hexagon. No, we don't want that because that was all fucked up. Let's see. Really? Okay. So 92. Let's make it 100. Come on. 105. Okay. 20 millimeters. Let's try to bevel it. I absolutely hate that. I absolutely love that. Okay. Okay. Let's make that a little bit more of a bevel. That looks good. Okay. Let's do this. Let's do this. Let's do this. Let's do this. Control D. 180. Really? That is 21. That should be 20. Yes, it is. Okay. Now we should take this and this. Line on you. Here, here, and here. Now we bring you here. And now I want 0.3 millimeters, 3, 6, 9, 12, 1.2. So we bring it this. Negative 1.2. Okay. Ow. Now we turn this into a hole. Nope. First, we join it with this. Okay. Okay, that should be a solid. Okay. Turn it into a hole. Join it with this. Join. Okay, there is our insert. No, that is incorrect. That will not work. The insert needs to... Actually, no, it doesn't. It does not have to go all the way around. It's totally okay for it to be open like that. And then we join it with this. Okay. Now, did that not cut? It did not. Well, don't that suck? You have to punch all the way through like that. Don't be a douchebag. Do as you're told. There we go. Oh yeah, that's beefy enough. Okay. Okay, that works. Okay. You and you. Align on you here and here. And then we bring this way. 1.2. Negative 1.2. There. Now that sits proud enough to not roll. And now this will be printed in TPU and this will be printed in TPU. Okay. Now, the only question is, will this be strong enough? Now, this will have to be made just a hair bigger. So this will have to be, let's see, 91.5, 91.5 by 105.5. So it'll friction fit on top. I still have to figure out how to attach it. Do I just glue it on? I might just glue it on, but that destroys serviceability. I might need to make these base layers a little thicker so I can have a recessed hole and have two screws, like a screw here and a screw here, to hold this on. I like that. I actually like that a lot. How big is this? We are looking at, woo, this thing's 12 inches long. Okay, that's a little bigger than I thought. We could probably make this quite a bit smaller. That's way bigger than I thought. Okay, this is a chunky boy. Yeah, it's 4 inches tall. That's right. It's 100 millimeters. That's 4 inches. Yeah, I got to go too. 2:08. I got 20 minutes to make it to the Roadrunner. Yeah, I'm probably going to make this a little shorter. Take like 4 inches off the length of this. It doesn't need to be this big. Yeah, it's way bigger than I need it to be. So yeah, I'm going to shorten this about 4 inches, but yeah, that's about it. I like it so far. If you could think of any improvements, let me know. Anything I should add. I might add a USB converter to the tail cap so you can use it to charge your phone, for example. It's not really necessary, but if you're going to have this gigantic a battery, might as well take advantage of it. Okay. Why did you turning on? All right, I think that's it. Yeah, I definitely like this better than the square one. So I'm not even gonna. Square one's gone. I don't like the square one at all now. Yeah, now that I have this, I much prefer this. Now, if you really wanted to go stupid, I could put two of these batteries in here and you can have a 2P configuration. 40 amp hours to power a flashlight. That's a bit overkill, but it would last a long time. Holy shit, would it last a long time. Okay. Okay. I think I'm good. Now, something else I could do is I could put because this is so large, I could put a second emitter in here. There's enough room to put two heat sinks and two emitters in here. That is something I could consider. Then have two switches. And that's still below the threshold for the constant current linear driver is capable of 9 watts. And since I'm going to be running these at 4 watts, I could run 2 of them off one constant current linear driver. So I wouldn't have to, all I'd have to do is add a second emitter and a second heatsink. So I might do a dual head version. Same exact size, but with 2 emitters. Man. Yeah, I might do that. But that'll be later. I gotta think about it. It wouldn't be that hard to do. Wouldn't be that hard to add a second emitter to this. There's plenty of space. Okay. All right. I will see you guys later. Thank you for joining in. Don't forget, you can help me out. You can send me a Zelle, a coffee, a PayPal. You can join my Patreon. You can use my Amazon link. Don't forget, I have a Discord. Oh, I wonder what movies are available today. If I had legs, I'd kick you. What? Okay. Do I even want to know what that's about? Okay, I don't know what that's about. It looks boring. All right. Um, that's it. I will see you guys later. Let me do a screenshot for YouTube, since right now the screenshot's from last week, which doesn't fit this. Man, is this thing struggling. All right. You guys have a good night. Be good. Be happy, victims. Come on, close, 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 close. Struggle, 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 struggle. All right. Oh, where is it? Where is it? Why can't I scroll? Right here. Yeah, I'll probably use the nice soft stuff. Although even the rigid stuff would be plenty flexible enough to give you the bounce you need. Oh, because literally all you need to do is, 1 order of magnitude change in the time span for the impact, and that's all you need to stop it from tearing itself apart. And that would be enough. But yeah, you can make it out of really soft. So whatever you have, basically, any TPU will work. Any TPU. That's it. I will see you guys later. Be good.